Good afternoon. Welcome, everyone, to the session, Automation for the Humans, Developing Automation with the Humans in Mind. I am, of course, as you might have already read, Michael Ducey. I work for Chef Software. How many people who have used Chef before, the open source software project? Yes, good. A few of you. I'm the Director of Product Marketing. You can reach me on Twitter if you want to say hello or anything else. Right there, MFDII. So, as we talk about how we go about the process of developing applications, so what's one of the first things that you need to think of when you have a new idea for an application? The next thing you have to think of is what? Well, the next thing you have to think is a rather large crowd, so it might be hard to do a question and answer thing. The first thing you have to think of is the infrastructure that you're going to go and run that particular application on. And so, are you going to run it in your own data center? Are you going to use traditional methods like VMware? Are you going to go down the path of cloud and infrastructure as a service? Are you going to use containers? Are you going to use platform as a service? Are you going to do this newfangled thing called serverless, where you don't have servers at all and you just run functions in the cloud? So take, for example, Jane. Jane's an application developer and she's pretty smart, so she comes up with this new idea for starting a particular idea at a company. So what she realized is that she had this real super smart idea and she wanted to try and get this idea out as quickly as possible because she thinks that she can be very, very rich off of this idea. The builds are a little delayed, sorry. So she thinks about her time at the companies that she's worked for in the past and how they went about building software. And she knows that they have a lot of application code that they run that's using a particular application platform. And they use this particular database platform, and they use this particular web tier and this infrastructure. But she also knows that everyone's really upset because there's this idea of technical debt in the application stacks that they're using now. And so she thinks, well, is that really the right path that she wants to take for her new $1 million idea? So she starts back to square one because with this combination of platforms, she knows that there's a lot of sadness, or as they say, sad pandas, with this particular application stack. So she starts over at square one, and she thinks again, where should she start coding? She starts doing some research, and she realizes there's this new thing called cloud, and she's going to go down the path of using a particular cloud provider. And so she gets the particular VM service from that particular cloud provider. She can use that to run its application stack that supports her language, and she can build there. And so she realizes pretty quickly that she's going to need to use the infrastructure as a service provider's database platform that they offer as well. It's not entirely the same as what they use at her company, but it's very similar. Then there's a whole web tier that she needs to actually add on as well. And the nice thing is that this infrastructure as a service provider has a web tier that she can easily go and deploy her web applications on. And so it feels like she's getting rid of some of the complexity and walking away from that complexity. Well, what she starts to realize pretty quickly is that they were using a lot of this infrastructure as a service product, right? And so they've tried it at her company where she works now, and all of a sudden the bill gets very, very expensive. And when the bill gets very, very expensive, what happens? Well, of course, more sad, in this case, sad female pandas. And she remembers that when her company tried this thing called cloud and they got basically tied into a particular cloud provider, when it was time to try and move off of that particular cloud provider because it was becoming too expensive, it took them over 12 months and a really large effort, and with her $1 million idea, she really doesn't have time to do that. So Jane's smart and she doesn't want to go through that process of getting locked into a particular cloud provider. So she goes back to square one. She heard about this new thing called containers, right? And containers sound really interesting to Jane, and she thinks that it could actually solve her problem. And so she downloads very quickly, just running a command, she downloads a container that can run her web application. She downloads a container that can run the application backend, and she downloads a container that can run the database. So on her laptop, all of a sudden, she's moving very quickly. It feels really good. She's once again able to begin that process of going down the path of writing her application and not worrying about the infrastructure. And so she's super delighted. She thinks this is great. And what she realizes pretty quickly is that something breaks, or she tries to make a change to a particular function, or she needs a particular library in her application code. And so she's trying to implement this function and using these pre-baked containers, and what she realizes pretty quickly that the pre-baked public container only gets you so far. As soon as you go outside of what that pre-baked container gives you, you have to start writing and maintaining your own custom containers. And of course, that's what Jane does. She writes a build file, she takes that build file, and now she has her new fixed application. And so she's happy, and she feels like she's moving along a little bit, but not as fast as she was moving along before. And so, Jane starts to think about all the other challenges that might lie before her. She's already encountered some, and she's starting to get a little concerned. So she starts thinking, and remember, Jane is smart. She's practicing DevOps, she's a brilliant developer, and she also understands operational challenges. And she goes down the path of what would it actually take to take that application that's running in the side of these containers, and how can I actually go and actually deploy it in production? And so what she realizes pretty quickly is that she's going to have many, many containers, and these many containers are going to have different personalities or personas. She'll have a bunch of web, she'll have a bunch of app, and a bunch of database containers. And somehow she needs supervision, she needs orchestration, she needs service discovery, she needs monitoring for all of these different application containers that she's going to have out there. And so what Jane realizes is that pretty quickly she starts doing research, and she realizes that there's a whole bunch of different supervisors out there. There's a whole bunch of different orchestration providers out there. There's a whole bunch of different service discovery tools out there. There's a whole bunch of different monitoring tools out there, and she realizes pretty quickly that it's getting much more complex than she initially thought it was going to be. And all Jane wants to do is write an application. Jane doesn't want to need to think about all of this complexity that it's going to actually take to run that application in production. And so she gets frustrated, and she starts to think, well, I don't want operations as part of the process, right? And so she talks to her friend, and she realizes that she should just use platform as a service, right? I mean, all of the problems and challenges that Jane are running into are supposedly taken care of by a platform as a service provider, right? So Jane starts digging around at options, and she realizes that she can take her containers or her application, deploy it onto the platform as a service, and now she feels like she's going really, really fast. So she was able to take that piece of code, drop it right onto the provider, and now her application is running. So she thinks it's great, it's fast, it's easy, she can get to focusing on what actually provides value, and that's the actual application. And then all of a sudden her app breaks, she has to go and write that function again and write a new part of the application. And she's wondering what to do, and of course now she's slowing down because she's having to go and write this particular second application as well, and her application grows, and I'm not going to go through all of this because this follows the exact same pattern of the different ones that we had talked about before. So there's no magic bullet to any of this. It gets really, really complicated really, really fast. And so how do you keep that? That was a lot of building, wasn't it? So it gets complicated extremely quickly, and what you start to realize is that none of these platforms were actually built with humans in mind, and realizing how can I reduce the complexity that the humans have to actually go and encounter on a day-to-day basis when they want to go and deploy their application. And Jane's very upset by that. So let's talk about what's actually going on a little bit from a more maybe economics perspective, or what's actually going on in our worlds and how our worlds are changing. So there's this thing called Jevons paradox, and Jevons paradox is about elastic demand, right? So basically what this graph is saying to illustrate Jevons paradox is that if there's a reduction in the cost of fuel, what's happening is because fuel is cheaper, then people are actually willing to travel more, right? So right here, there's a 20% decrease in the cost of fuel. So it's gotten 20% cheaper. And because it's gotten 20% cheaper, people are actually using 40% more of it, right? And so go back and think a little bit about what's happening in our industry, and if you said in the keynote, you might have saw this exact same idea take place in the keynote, where you have many, many more, these are bare metal machines, but all of a sudden virtualization containers and other things like that, we have millions of more machines to actually go and manage. And the reason for that is this diagram right here. What has happened to the power of compute? Power of compute has gotten greater and greater and greater over time. And what else has happened to the power of compute? Or I'm sorry, to compute itself? It's gotten a lot cheaper, right? So as compute has gotten cheaper and cheaper and cheaper, what's happening is we're using more and more and more of it. And that's why we see a graph like this as far as the number of VMs that we're using versus the number of systems that we actually have deployed. And guess what? It gets worse. Because by 2019, this one source, and if you look at this, there are many, many sources that say the exact same thing, and the CIO said it today during the keynote as well, is that we're going to have billions and billions and billions and billions of devices out there that we're going to have to manage. And of course, we all saw what happened today with Internet of Things devices that aren't secured properly. We all know that while we were sleeping here in Tokyo, there was a major internet outage in the United States. So things like Netflix was down, Etsy was down, GitHub was down. All of these major sites went down. Luckily, we were asleep during it, so we didn't have to deal with it. But what you realize is that there's just going to be much more complexity when it comes into managing all of these different devices. And while we may not necessarily need to automate all of these devices, what's going to happen is that the connected devices grow because of cheap compute. The growth of data generated by these devices, so we're going to have more and more data that's actually being pumped out of these devices. And what happens is when there's more and more data, what are we going to have to do to the data? Well, we're going to have something to store it and process that information and make something useful out of it. So with every one Internet of Things device out there and it's generating data, think of all the compute power behind the scenes that has to be available to store that data and process that data and make something meaningful from that data. So the current automation that we have in the industry cannot scale to the next level of compute, to these billions and billions and billions of devices. So we need to think of something different. And that's where we talk about this looming complexity crisis. So typically what we do is when we start thinking about how we're writing our applications and how we are going to deploy our applications, right away we buy into solutions before we write any business logic. So the example with Jane earlier is that before she was even worrying about actually going and deploying her application or writing one line of her application, she was worried about how she was going to deploy that application out to the world. You have to deal with this complexity first, because if you don't deal with this complexity first, it can derail you later, right? And the infrastructure choices often design or dictate the design of the application. So depending upon what type of machine you're going to put it on, or whether if you're using containers or you're using traditional VM instances, your application is going to have to be designed differently. And of course, we all know that if you are going to write your application for a mainframe, it's going to be even more, because we're still doing that, right? Any mainframe programmers in the room? Nobody laughs at that? Everyone knows mainframe. Come on. And the other challenge is that there are just more and more application stacks. So with more open source frameworks happening every single day, there's much more complexity on the application side as well. Typically what we do is we go throughout this process, and what we do is we write infrastructure first. So we think of the infrastructure challenges first. The challenge though is where is all the value? Where are you going to make money? Do you make money off of the infrastructure service provider that you decide to choose to run your application? No, you make money by having your application available and usable and consumable by customers that are going to pay you money. And so it's really a backwards approach with unintended side effects. And those unintended side effects are things like higher complexity, higher error rates, not scalable, and other things like that. And so what we want to try and do is help you start with the business value and work your way down. And this is really, if you look and study about humane systems, which is actually a passion of our CTO at Chef, Adam Jacobs, he likes to talk about humane systems, and he did a really excellent talk about the design of habitat and how he approached it from a humane systems approach. But automation, really the goal is that automation should reduce complexity, so it should make it easier for the humans to understand what's actually going on inside of the system. The automation should inform humans rather than mechanize them. And so an interesting thing in the keynote earlier today, when the CIO was talking about how AI can actually help humans progress along that cycle, right? And so the same thing happens with automation. So this automation should help humans actually inform and help them make better decisions versus just taking away the ability for the humans to turn the knobs, right? The other really important thing is that automation should reduce errors, because once again, it's about making the humans' jobs easier. And then lastly, automation should help liberate you from the actual complexity, the infrastructure choices, from your job to a certain extent, and give you a higher purpose or higher reason for your job so that you can begin to think more strategically. Also along those lines, think about how you begin to develop from an application first perspective as well. So if you take a step back and think, I'm going to write an application I'm going to start developing a new application from an application first perspective, the things that you need are, the application would need to know how to configure itself, right? So it needs to know about its environment as well. It needs to have all of its dependencies defined as well. So all the way from dependencies from other applications that it needs to talk to, but also library dependencies as well. It needs to know how to adapt to different topologies. So you might take an application, and when you deploy it in development, it has a different topology because you don't have that many machines, but when you go and deploy it into production, you have a different topology because you need to run it at scale. It needs to know how to respond to changes automatically. And then it also needs to act with isolation and immutability. So it needs to be isolated from its peers, where if it goes down, it's not necessarily, or a component of it goes down, your application peers can actually know that that went down, and you're not going to bring down the entire site. So let's talk about isolation and immutability a little bit. So immutability is really important so that you know exactly what you deployed is the thing that you have running out there in production. So what you want to try and do is you want to try and ship this immutable artifact, but the problem is when you ship this immutable artifact, you might need to make small level changes at runtime. So a great example is that, so everyone knows that a container is what's defined as immutable infrastructure. But the problem is that there are little changes that need to happen to the application or to the application runtime based upon the environment that it's running in that you need to inject into the running container. Now typically that's been done traditionally through something where you just set an environment variable, and that environment variable is read at runtime by the actual application, and then the application configure itself appropriately. And Docker allows you to do that by injecting in those environment variables. The first time that you realize that this doesn't scale is when you put a password in that environment variable, and now you realize that this password is, because that's the only way that you can inject configuration into the running container, you now realize that this doesn't scale. And so you need something else to handle those minute changes that you need to make at runtime. And the other interesting thing about isolation and immutability is that you want to try and isolate from downstream dependencies. So downstream dependencies, when you think of this, there's a couple different downstream dependencies that we're really stuck on that we're starting to move away from slowly in the industry. The first downstream dependency would be the operating system, right? So if you look at most container build files or Docker files, the very first line is that you're including Ubuntu 14.04 or 16.04. And the first time that you have that line in your Docker file that says from some sort of an operating system build, what you've now done is you now have locked yourself to all of the dependencies inside of that operating system, right? And so when you want to try and move that application off of that operating system, if you don't know what dependencies you're consuming from that operating system, you're not isolated, and it's going to be very hard to do that. There are some past experience that we can build from in building this automation. So the first one is that we know that if you don't isolate infrastructure choices from the app, you're going to increase the level of complexity. Runtimes are evolving very, very quickly. And the challenge is that with many runtimes, you only focus on workload placement, right? There's also a lot of restrictions in these runtimes about what languages can be used for them. And what you really want is you don't want restrictions on language or the execution model. You want those choices to be made by the developer at runtime. And that's why containers actually give you a lot of that flexibility. But if you look at a platform as a service, you're very, very restricted into what languages the platform as a service provider are actually going to provide for you. And a really, really key one is how can you support legacy applications? So how can I package up my legacy applications in a way that provides an interface around them so that I can run them in a more effective manner, more like a modern system that I would want to. So, how to develop in an application first method. So start with the behavior and the business value. So start writing the application first. Build in isolation and immutability into the application. Have a mechanism to dynamically configure the application. Allow your application to go and respond to those changes in real time. And do that anywhere, and do that the same with new applications as you can with legacy applications. So it sounds kind of grandiose, very large statement, and a very difficult thing to achieve. But we feel like we've done it with something called Habitat. So Habitat is an open source project. It's built by the people who brought you Chef. It's completely open source, and at the end there'll be some links that you can go and learn more about it. The other thing is that if you stick around until the end, we have a bunch of Habitat t-shirts, just like the one I'm modeling to you, and stickers as well. So feel free to come up and grab a t-shirt and some stickers as well. So what is Habitat? So Habitat is a couple things. So the first one is a studio. The Habitat Studio allows you to take an application and package up that application and all of the application's dependencies. There's what's called Habitat Plans. Habitat Plans are basically a bash script that allows you to take any application and package it up into this reusable or immutable package that you can then distribute to different servers. The Habitat Depot is where you can take these packages that you create with the studio that come from a plan, and you can upload and download those packages. So basically it's a depot or an artifact repository that we provide. And then a Habitat Supervisor. And the supervisor is basically built intelligence into those packages. So the packages allow you to define configuration settings that can be changed at runtime, and the supervisor will take those configuration settings that you've declared that should be changed at runtime, and when it launches the application, it'll make those minute changes that you need to the application runtime. Additionally, it has service discovery built in and also deployment coordination as well, which we'll talk about that here in a second. So the first part is that there are Habitat artifacts, and we call them heart files. So the Habitat heart files are essentially generated by the studio, and then you take that Habitat artifact, you store it in a depot, and then that artifact goes down from the depot into the actual running instances. So the first thing you do is you take a plan. The plan basically is a shell script. I'll show it to you here in a second. You generate an artifact and you store it in a depot. And then once it's in the depot, it can be ran on any of these different platforms. So the interesting thing is that you can take this application package that you create and run it on bare metal, run it on containers, run it on an instance in a cloud provider, or run it on a VM in your own data center, right? So the behavior is going to be the same no matter what infrastructure runtime that you choose. I'll show you all this here in a second, so I walk through all of this. The other piece of Habitat, which is something that we plan to launch in December or towards the end of the year, is a build service. So basically you have a source code repository, you have a plan in that repository, and you make a change, you submit a pull request, and then the build service will pick up that change, generate a new artifact for you automatically, so build it for you, and then store it in the depot. It'll also test if you need to have any testing done, or if you need to go and pull down any also dependencies as well. You can have those dependencies pulled down and checked as well as part of this process. Now this is where things become a bit more interesting because we can actually begin to run our application. So then what happens is you have this artifact, the heart file, in a depot, you take it from, you take that artifact and you put it on different supervisors. So instead of the traditional command and control methodology that is common in many configuration management languages, like Ansible and Chef and Puppet, Habitat actually what it does is each supervisor is independent, and every single instance of your application would have a supervisor running on it, and that supervisor, those supervisors then begin to communicate with one another to build what's called a service ring. And through this service ring, they can pass things like secrets, configuration changes, and so forth. If one member of this ring goes down, then all the other members will figure out that that member has went down, and they will go and take appropriate action. So if that means they all need to reconfigure themselves because a member has went down, then they would all go and reconfigure themselves. And there's also different topologies that you can build into this as well. So you can have a leader-follower type scenario. So maybe you have one instance come up first, and then you have all of the, like a load balancer, and then you have all the web servers come up afterwards, and they automatically join and communicate with one another. Oh, the other interesting thing is that the supervisor has a REST API. So this supervisor actually launches the application, but then it also exposes different API endpoints where you can do things like check the configuration of the running service, you can do a health check, you can get a generic status check as well. And you can also find out information about the gossip protocol, or I'm sorry, the gossip ring that it creates. And you can also see what's happening from an election perspective as well. So what happens is say, for instance, you're running a Redis application. What will happen is one machine will become the leader, all the other machines will become the follower, and that's done through an election process. If the leader dies for whatever reason, then they will recognize that their leader died, and then they'll start that election over to go and reconfigure themselves dynamically. And I just pretty much kind of told you about that. So with the ring, you can inject secrets or configurations onto the ring so that the machines can dynamically configure themselves. So say, for instance, something has changed in your environment, and you need to tell all of your machines that the JDBC connection string is different if you're running a Java application, for instance. Then you can inject that secret in, or that piece of information in. Everyone would recognize that there was a change, and they would all take appropriate action, which would most likely be reconfiguring themselves. And with the API, you can actually use that API to do queries and actually get information back so that you could have maybe external load balancing services or something like that available to you. So we pretty much talked about all of that already. So Habitat's approach. So applications, our approach here is that applications run as distributed, fully automated, and autonomous actors. So each Habitat application can be completely autonomous, or they can be dependent upon other members in its ring. They're immutable applications, so the application artifact itself is immutable. What is not immutable, or what is mutable, is the actual configuration of the application. So you're able to change those minute details that you need to change at runtime. It bundles only the applications you need, or the application libraries that you need, and you don't bundle up all this other waste that you don't need running on the operating system or anything like that. The automation also helps you choreograph cluster topology or cluster behavior as well. And basically what it creates is that there's no single point of failure. So we're getting rid of that idea of command and control and you're running your applications. And it provides continuous deployment without this traditional application release automation pattern that we've seen in the industry for a number of years. So, what is Habitat? The best way to explain what Habitat is, besides all of the words that I just used, is that it's application automation that allows modern application teams to build, deploy, and manage any application in any environment, from traditional data centers to containerized microservices. Make sense? Probably not. Would you like to see it working?
Yeah.
Yes. I hope the answer was yes. I mean, it can be no as well, and we can end right now. I won't be offended. So this is kind of small. Okay. So the first thing I'm going to do is I need to enter my studio. And what the Habitat Studio is it's a container that we provide. And inside this studio, it basically is, think of it as a clean room, right? So you want to make sure that you don't get any contaminants in your application, and you want to make sure that you only have the libraries that you need. So if I'm already in the studio, I started the studio earlier, and it's really just a real simple command. Somewhere, we won't worry about that. So it's basically have studio enter, and you basically will launch a container for you. If you go to habitat.sh, you can download the Habitat binary, and it'll also tell you what else you'll need running as well. So in this case, you'll need Docker running, obviously. So I have a whole bunch of different plans, and you can see all of these different plans that I have, and these are all the different things that I could possibly build. So you can see there's one for MySQL, there's one for Tomcat, Nginx, and other things as well. So let me just show you the Redis plan. So the Redis plan is actually fairly simple. So you notice, if you've ever written bash, you notice that this is just generic bash. So it's plan.sh. There's a bunch of metadata or variables that you need to set at the top. So one thing that I've set is where do you go and download Redis from. Other important things that I've set is what are my build dependencies. So what are the software that I need to build it? But the software that I need to build the application may not necessarily be the software that I need to run the application, right? And so you don't want to have build time dependencies inside of the artifact that you go and you ship out to production, right? Because if I shipped out my build time dependencies, what am I going to ship to production in this case? GCC. Should you have GCC running on a production system? Ideally, no. So when I actually go to ship this, the only thing that I need to ship is glibc. And some other metadata information about how I start the service, and then also what port should I expose. Now the other thing that I have here is there's a whole bunch of different functions that you can override, and all of those are on the documentation site. There's like install, there's download, there's build, there's a whole bunch of other, there's probably about 12 of them that you can override. And so all you need to basically do is to build the software, I just need to run make. And that's it. That's all I have. So what this is going to do at the end is it's going to spit out a heart file, and that heart file is basically a tar.gz file, and it's going to have a compiled version of Redis in it, right? The other thing that's in this is a default.toml. And this default.toml is basically all of the configuration settings that I want to expose to the end user that the end user can overwrite, right? So you can see there's the port that I'm going to listen on, TCP backlog setting, and there's a whole bunch of other settings that you can go and change inside of Redis. All right? So what I want to do is I want to have Habitat actually package this up. So I just need to say build Redis. And this is going to take a second because it has to go and it has to pull down all of my dependencies. So what were the dependencies that I said that I were dependent upon? To build, GCC, and make. Now it's went and downloaded specific versions of glibc and also specific versions of make, as actually is taking latest. What I could actually do is I could actually call out that I wanted a particular version of glibc because my software has to be built against a particular version of glibc. But also if you're thinking about from an application world, you would also be able to go and actually call out specific libraries that you need inside of your application as well to make sure that those application libraries are brought down. And so now what it's doing is it's actually going and compiling the software. All right, so it's done. So what it's done is it's went, downloaded my build dependencies, and then now it's actually generated a package with Redis inside of it, right? And you can see where it's actually stored, right here. And you can see there's the actual file that I just created. So what it says is it's 3.2.3, and then the actual build time as well, when the software is actually built. So now what I want to do is I want to export this. So I want to export my application and all of its dependencies and I want to take it and I want to make it in something I can actually go and actually start to get value out of it, right? Some sort of artifact. So if I run have package export, you can see that, well, I've lost some information, so let me just do a help. And what I can do here is you can see here that I can export this package as a Docker container, as an ACI container, as a Mesos container, or it's just a normal tar file. And so if I say have export Docker mfdii/redis, so what it's doing now is it's going and downloading some dependencies from the depot, and these dependencies are needed to actually go and build the actual container. So you notice that it's downloading a bunch of libraries, and now it's actually going and building the actual Docker container. So you notice that we start from scratch. The other thing that you notice is that it's went and basically set an environment context or a runtime context, right? Or an execution context. And you notice that instead of using anything that's in user lib or lib, I'm basically overriding everything to go and pull directly from Habitat packages, right? So that's one thing that Habitat does, is that when you declare these dependencies explicitly, it goes and sets the execution context so that you're using the actual dependencies you declared and not some random dependency that's been deployed onto the operating system. So great, so it's actually went and built a container for me. And if I do Docker images, and you can see 42 seconds ago right there, I went and created this container. Now it's a little large, but it's smaller than these other containers that I've created. All right, so now let's actually go and begin running our application with this container, all right? So all I need to do now is I can do docker run -it. And sure enough, it's happy, it's went, and it's launched Redis for me. And you notice that the supervisor has actually went and launched it. So the supervisor starts, it generates the configuration file for Redis, and it's actually brought the application server up and it's running. So great. You also notice that there's some settings that it's complaining about as well. So it's complaining about this TCP backlog setting, right? So if in the traditional world, if I wanted to go and change this, what I need to do is I need to go and basically change my Docker file and have the Docker file have a configuration in it, or include that and rebuild my container. What I can actually do is I can go over here and I'll just open up and the setting it's complaining about is TCP backlog, and we'll just set it to 128. And now I want to go and tell this machine that's running to go and update its configuration. So the name of the service group is Redis config. Let's do a 1. Now when I hit enter, you'll see on the other screen, hopefully, well, it didn't like that at all. So let me do this, docker run -it. So I'm going to ask what can I configure about Redis? And so if I go over here and basically run docker run and then say config the name of the package, it'll actually go and spit back everything that I can actually go and configure about this particular container. And TCP backlog should be one of them. Well, I have no idea why that didn't work. So let's try it with something else. So let's do this. Let's actually bring up multiple ones of these. And what will happen is since I said I wanted leader follower, just by specifying -T, it's going to sit there and wait until other machines come up. So if I go over here, I can do the same thing, -T leader. So you notice now I've got one of two, and if I just brevity, we'll go over here and run another one. So you notice now 3 of 3 have actually come up, but you notice that this one's actually complaining it can't connect to the master, and this one over here, it's accepting connections or trying to set connections. And you also notice that it's done an election, so the leader follower thing is set up. And you also notice this one is complaining about it as well. So basically what I need to do now is there's a setting that's not set correctly. And if I go and type in protected mode, no. And I take this configuration, and it should work this time. There we go. No. Well, I always love it when a demo doesn't work the way you expect it to. So I'm going to stop trying because time is almost up. Well, what they should have done was take this actual configuration and ship it onto the ring, and then all of them would have got this configuration information and reset themselves correctly. But I love it when a plan doesn't actually work the way you expect. So let me give you some resources so you can actually go and try this on your own, and I guarantee it'll work for you. So if you want to try Habitat and learn more about Habitat, you can go to habitat.sh or habitat.sh/try. There's tutorials, there's a getting started guide, and extensive documentation. It is open source, so Habitat's fully open source. You can contribute to it. There's a whole bunch of different plans. There's about 400 different plans right now for the different libraries and software that you might need. And we also have t-shirts and stickers up here as well. So there's a whole bunch of t-shirts. There's some chef shirts, there's Habitat shirts, and stickers as well. So with that, sorry that the demo broke. I tried it before and it worked. But that's always the case, right? With that, thank you very much, and thank you for taking the time. Questions? Yeah, any questions? Yes?
How is this different from Kubernetes, and what are the qualities that used for maintaining the state, especially in terms of microservices?
So the question was, how is this different than Kubernetes, and what does Habitat do to maintain the state and make sure the state is persistent in terms of microservices? So what Kubernetes doesn't provide to you is a way to build the containers. So one thing that we actually do provide is this build system, and that's the Habitat Studio. So you can have a bare operating system. So you notice we didn't start from Ubuntu or something like that. We started from the scratch image, so an empty image, and then we include all of the different libraries that you need to actually go and run the application and run the automation. And then Kubernetes would sit on top of Habitat and control the containers, do the deployments of the containers, inject configuration information as well, read the REST API that's there as well as part of the supervisor to take any actions that Kubernetes would need to do. So they're definitely complementary. And as far as storing state, that's one thing that we're actually working on and need to figure out a good solution so that we can have this state store and that information can be passed onto the ring dynamically, either at launch time or when a state change takes place and that configuration needs to be injected. We've only had Habitat around since June, so it's still a very young open source project, and then there's definitely some of those questions like that that we're trying to answer. Thank you. Any other questions? Well, if you want to ask a question, but you just don't want to ask a question in front of such a large room, I'll be around later during the beer bash at the end, and we'll be here the rest of the afternoon as well. So thank you very much.